I'm going to set this up. I have an unbounded region, so because my bound is infinity, so I'm going to set this up with a limit. So limit as a goes to infinity of the integral of 1 to a of 1 over x squared dx. Okay, I'm going to integrate that. Okay, using power rule, this is going to be negative 1 over x, and the bounds are 1 to a. And then I just can evaluate this by applying my limit. It becomes negative 1 over a, which is going to infinity, minus negative 1 over 1. That works out to be 0 minus negative 1, which is 1. Okay, so the area underneath this curve, so I'll just sketch it out, 1 over x squared curve from 1 to infinity, this area happens to be 1 unit squared. Okay, so looking at this next one here, the cube root of 1 over the cube root of x, we should really just have a quick idea of what this looks like. It's going to be a reciprocal function that goes like this. So it's going to dive down to 0, not quite as fast, much slower actually than the 1 over x squared. And since the domain is all negatives as well, it's going to look like that. And we have an asymptote at 0. So we have to be careful when we integrate this, because we're going to integrate from negative 2 to positive 2. Now, if you take a look at this graph, well, that area here, the unbounded region with the y-axis, and the area here, the unbounded region with the y-axis above, well, those two areas are symmetrical and they cancel out. And we have to be careful, because if we don't set this up as two separate integrals, you will find that these two areas do not cancel out. Okay, so how do I set this up? Okay, I need to use a limit, okay, and I need to split this into two separate integrals. So I'm going to do the limit as a goes to 0 of 1 over, so the bounds are negative 2 to a, and there is my integral. Okay. Then I need to find this area, and I need to add that to the area on the other side. So as a, in this case, goes to 0, and sorry, this one is 0 from the, it goes to 0 from the negative side. This one's going to 0 from the positive side. Okay, and then the integral from a to positive 2 of 1 over cube root of 3 dx. Okay. I'm going to anti-differentiate this. That's power negative 1/3. So this becomes the limit as a goes to 0 from the negative side. Power 1/3 becomes negative 1/3 becomes power positive 2/3, and divided by 2/3. So there's my coefficient, and my bounds are negative 2 to a, plus the limit as a goes to 0 from the negative side, or sorry, the positive side, and this is going to be 3 over 2, same thing, x over 3 over 2. And the bounds in this case are going to be from a to 2. Okay, so then as I plug in here, I'm going to go to 0 from the negative side of this function. It's going to be positive. Okay, if you graph this function, if you watch it go to 0 from the negative side, it's going to go to positive. Actually, sorry, this is, you don't have to worry about that, sorry, because that's in the numerator. So we're just going to put 0 in. So I'm going to end up with 3 over 2, 0 to the 2/3, okay, because we plug in 0 for a, minus, when I plug in negative 2 there, I'm going to square it and cube root it. So it's going to be the cube root of 4. Okay, plus 3 over 2 here. We're going to do the same thing here. I'm going to end up with plugging in the 2 into here. So I'm going to, oops, should have been 2/3. Okay, so I plug in the 2 in here. I'm going to square and cube root. So I get the cube root of 4 here minus, when I plug in 0 into here, I'm going to end up a equals 0. When I plug the 0 into here, we end up with 0. Okay, so there's our integral. And if I take a look, it's going to be negative 3 cube root of 4 plus cube root of 4. Those two areas cancel out. So I end up with net area of 0, which is what I should expect because the same area is above and below. Okay, and if you tried integrating through that asymptote, you'll find that you get a little bit inconsistent value going and doing that.